All right, my beauties, we are now moving on to scatter plots, and this set of notes is just looking at correlation, not actually writing any equations yet. So a scatter plot is a set of points, but we've collected it from real life data, so it doesn't end up forming a perfect line. So we are hoping that it forms some sort of shape, and if it does, that's what we call correlation. We're basically saying, do the points follow a pattern? And we are hoping that they form a pretty straight line. That's what we want to see. So for example 1, we just want to look at the points and decide if we think it's a weak, moderate, or strong correlation. And if it does look like it follows a pattern, do we think it's a positive linear, negative linear, non-linear? So it does form a pattern, but it's not a line. It's some sort of curve, or just basically no shape in general. All right, so for A, we just kind of have these points all over the place. So this would be a very weak correlation because there's no shape at all. I don't see any line, any curve, anything. It's just a bunch of random points. All right, so for B, I can draw a line that goes through the middle of these points, and it really does follow the points. So I'm not sure if this is moderate or strong, but I'm just going to say moderate. So I'm going to say it's a moderate correlation, and it's negative linear because it's going downhill. Okay, so downhill, negative slope, so it's a negative linear correlation. C kind of confuses people because a lot of people say it's kind of weak to moderate unless you realize it's a curve. If I actually draw a curve in here, in this case it looks like maybe half of a parabola, those points really get close to that curve. So this is actually a strong correlation. It just happens to be nonlinear. And D, I can draw a line going through these points, and it hits a bunch of the points, and it's really close to the other points. So this one is definitely a strong correlation, and it's going uphill, so it's a positive linear correlation. All right, someone, a mathematician, decided to come up with a formula to decide if it is a strong, moderate, or weak linear correlation. And they use something that's called the correlation coefficient, and they use this lowercase letter r to represent the correlation coefficient. Okay, this only checks for linear correlation. Okay, so like on part C in number 1, it might actually have a really small r value even though it's strong because this is a curve, not a straight line. So that's one thing to remember. The r only tells you if it's a linear correlation. Okay, so 0 would be absolutely no correlation. So 1A would be pretty close to 0. Okay, so a positive 1 would mean it's a perfectly straight line, but so would a negative 1. A negative just means it's going downhill instead of uphill. Okay, so this doesn't tell you the slope of the line. It just tells you how close to a line it is. So if we're between 0 and 0.5 or between 0 and negative 0.5, that is a really weak correlation. That's not anywhere close to a straight line. If we're between 0.5 and 0.8 or negative 0.5 and negative 0.8, that's a moderate correlation. There might be something better, but it's got a decent strength to it. If it's between 0.8 and 1 or negative 0.8 and negative 1, that tells you that the points are really close to a straight line. Okay, so, and those are the values of r, the correlation coefficient. So for example 2, we would use a graphing calculator to plug all of these points in, and the calculator would calculate the r for us because the actual formula is real tedious and time consuming, so we don't worry about using the actual formula. So if we were to plug these all into a calculator, so for A, we said weak and negative 0.19. That is really close to 0, so that is definitely very weak. B, negative 0.95. Well, that's here between the 0.8 and the 0.1 on the negative side, so that is definitely a strong correlation. and it's negative linear. So my moderate guess here was actually wrong. This is actually strong, not moderate. So for C, we got R equals 0.91. So these points actually do have a strong positive linear correlation, but they actually would fit better with a curve than a line, but they do have a strong R value. And D, wow, look how close to 1 that is. So graph D has a correlation coefficient of 0.97, so that's way up here, really close to the 1. So that is a really strong positive linear correlation. And that finishes up scatter plots with correlation.